Greetings, math fans. All right, so this is worksheet 4, and just want to go through it really quickly here. All right, first part, it says state whether each of the following is a list of permutations, a list of combinations, or a list of neither type. Okay, so remember, you got to think with combinations, there is no order involved. All right, with permutations, you got some sort of order. There's some sort of arrangement. Think of the keywords that I showed you guys back in the day. All right, so list of possible ways of placing people in a row. Well, think about it. If I have 3 people, Judy, Tom, and Steve, okay, I can say, well, I want Judy, Tom, and Steve, then I want Judy, Steve, and Tom, or I want Tom, Judy. So in other words, there's a way to organize that. In fact, this is like the bride and groom problem. So this is a permutation. List of all possible poker hands. Well, what did I say about cards, right? Combination starts with a C, cards start with a C, so it's a combination. Number 3, a list of all possible basketball teams formed from a squad of 12 men, each of whom is versatile enough to play in any position. What you need to remember for that, we actually had a problem similar to that. I'm not trying to say that you got specific positions. I'm saying anybody can play any position. So basically I'm saying I need a group of people to play because anybody can play any position, forward, center, whatever. So that is truly a combination, okay, because there's no order involved. All right, number 4, a list of possible ways of placing 8 books on a shelf when 8 books are available. Well, kind of think about what's going on here. If I give you 8 books and I say, how many ways can you place those books, you don't just grab them and put them all up there, right? You can say, oh, I want book A, then book B, then book C. So the ways of placing them, I mean, think logically, there's order involved here, okay? So it's permutation. Number 5, a list of all possible selections of 3 books from a reading list containing 9 books. So am I ordering it? If I have books A, B, and C, am I saying I'm reading book A first, then B, then C? Or am I saying I just need 3 books? That's what I'm doing. I'm saying I just need 3 books. So there's no order involved here. It's just a group of books that I'm gathering. So that is a combination. Okay, number 6, a list of 3-digit numbers with which no digit repeats. This is not quite a combination. It's actually not quite a permutation because if you use the slot method, because you can't if I just draw 3 slots here, it's not a true permutation. Okay, because one of the deals is because you can't start with a 0. As soon as I start doing something different where it's not like a perfect permutation where I say, well, I could take these numbers, I can just mix them up, it becomes neither. So this is neither. Close to a permutation, but neither. A list of 7 contestants of the first, second, and third prize winners. Of course, there's an order involved here, first, second, and third, so that's a permutation. Okay, number 8, a list of cars available in 6 different colors with 3 different upholstery fabrics and 5 different interior colors. Now, truly, if I'm doing this as a combination, do you guys agree with that? So if I said it's like saying 6C1 and 3C1 and 5C1. Well, this is not really a true combination. A true combination is one combination of like saying, you know, if there's 14, it's like say 14C3, that's a true combination. So this one's actually neither. All right. All right, number 9. So the rest of these, again, you got to think is a combination or permutation before you even do the problem. So number 9, you are required to read 5 books from a list of 12 great American novels. In how many ways can you select those 5 books? Okay. Well, is order important here? No, I'm just grabbing a group of 5 books, so it's 12C5. Which is 792. Okay? A clown has 8 balloons, each a different color. There are 6 children, and how many ways can the clown give a child a balloon? Well, think about it. If there are different colors and I'm giving it to different kids, that means I can give Joey a blue one, or I can give Joey a green one, or I can give Mary a blue one, or Mary a green one. So there's like some order involved here because I can, you know, it's not like I'm saying I'm getting a group of balloons and I'm giving them to kids. Okay, so there's order involved here, and this is a permutation. So it's 8 balloons, and I'm giving it to 6 kids. So 8p6, which is 20,160. Okay, number 11, a license plate. First of all, if you guys remember, this is actually from day 1 or 2 with the slot method, and that's what you want to do with this problem. License plate must have 1 letter, followed by 4 digits, and followed by a different letter. And it says not I or O because I's look like 1s and O's look like 0s. So that means there's 24 letters left in the alphabet. You are probably asking, are there repeats or no repeats? Remember, you have repetition if it doesn't say so. So you're repeating, that means there's 10 possibilities, 10 possibilities, 10, 10. That's for the 4 digits. And then the last letter is we already used one of the letters, and you can't, it even says, followed by a different letter. So that means there are 23. Okay? And if you multiply all that together, you get 5,520,000 possibilities. All right, number 12. A box contains 12 black and 8 green marbles. And how many ways can 5 marbles be chosen? That's kind of what we just did. There are 20 marbles to choose from, and we're picking 5. So 20C5, which is 15,504. And how many ways can 3 black and 2 green marbles? Well, again, here's the word and. So there are 12 black, and we're choosing 3. And there are 8 green, and we're choosing 2. And you get 6160. Okay, how many 7-digit telephone numbers are possible if the first digit cannot be a 0 and only odd digits are used? That means you can only use 1, 3, 5, 7, 9. I don't have to worry about that 0 in this case, all right? So it's 1, 2, 3, 4, 5, 6, 7, and there are 5 all across here. If I multiply that out, I get 78,125. Okay, B, the number must be a multiple of 10. Well, let's draw our blanks here. 1, 2, 3, 4, 5, 6, 7. And if it's a multiple of 10, it's got to be, last digit can only be a 0. So there's only one possibility, right? Because like 10, 20, 30, 40, it's got to be a 0. We come to the first number, it can't be a 0, so there's 9. And now because, remember, this problem, there's repeats. Of course, it makes sense with a full number. It can have repeats. It's going to be 10, 10, 10, 10, and 10. So you multiply this out, and you get 900,000. Okay? Letter C, the first 3 digits are 885. So 1, 2, 3, 4, 5, 6, 7. Again, don't write 885 in here. It's 885 or 5. It's one possibility, one possibility, one possibility, and then you're doing the rest here. Then, of course, I can have zeros here now. So 10, 10, 10, and 10. So my answer to this one is 10,000. D, no repetition is allowed. Okay, different story. 1, 2, 3, 4, 5, 6, 7. Come to the first spot, can't use a 0. So there's 9 possibilities. I've used one of those numbers, but 0 is back in the pot, so 9. And now, again, it goes down, right? 8, 7, 6, 5, 4. Okay? We multiply all that together, and we get 544,320. All right, number 14. How many ways can committee? Oh, man, look at that committee. Oh, I like that word. Okay, committee. There's no order involved, is there? So it's 10C4, which is 210. And how many different salads can be made from lettuce, broccoli, radishes, tomatoes, and black olives? Oh, I love black olives. Well, remember, this is a similar problem too, but we can do 5 items. We can do 4 items. We can do 3 items. We can do 2 items. Or we can do 1 item in a salad, right? So 5 items is, of course, 5C5. And 4 items, 5C4, and 5C3, and 5C2, and 5C1. And, of course, it's 5 items or 4 items or 3 items or 2 items. Okay? And again, order doesn't matter. It doesn't matter if I have lettuce, broccoli, or lettuce, right? Add all those guys together, and I get 31. Okay? Number 16, there are 4 blues, 6 green, and 7 red marbles in a bag, and you pick 3 marbles. How many different ways are there to pick them if at least, ding, 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 at least, whoop, whoop, whoop. Okay, 2 of them must be green. So that means I either have 2 green or I have 3 green. So what I have here is 6C2, because there are 6 green, and I could put, again, well, what's the rest of the marbles? It's 11, right? Because look at, there are 4 blue and 7 red, so it's 11, and I'm picking one of those. Or, plus, I can pick 3 greens and 0 of the other ones. And if I multiply that and add it together, I get 185. Okay, 17. Out of 5 teachers and 7 students, a committee of 2 teachers and 3 students is to be formed. How many ways can this be done? It's a committee. It's a group of people. Any teacher and any student can be on the committee. So it's just going to be 5C2 times 7C3. Okay? 5 teachers pick 2, 7 students pick 3. That gives me 350. One particular student must be on the committee. That just means I still have 5, 2, but I take off I have one less student, so this is going to be 6, and I'm picking one less of them too. Okay, so I get 150 for that. Number 18, how many different homes are available if a builder offers a choice of 5 basic floor plans, 3 roof styles, and 2 types of siding? Okay, I mean, really, this is a good slot method problem if you think about it, right? 5 floor plans, 3 roof styles, and 2 types of siding. Now, I could have done it as a combination, 5C1, 3C1, and 2C1. But what is 5C1? 5. What's 3C1? 3. What's 2C1? 2. Okay, so my answer is 30. Number 19, how many ways can the word geometry be scrambled? There are 8 letters in geometry, and there's only one thing that's duplicated is E. So it's over 2 factorial. So you get 20,160. Okay, number 20, how many different 3-person groups are possible in a class of 30 students? Again, order's not important. I'm grabbing 3 people out of 30 students. No order involved here, so it's just a combination. So it's 30 people, and I'm grabbing 3s. 30C3, which is 4,060. Okay. 21, a math class is preparing for its final exam. There are 11 girls and 10 boys in class. How many different study groups consist of 2 girls and 2 boys can be formed? Okay, again, is order important? No, I'm just getting groups of 2 girls and groups of 2 boys. It doesn't matter. So it's 11 girls, and I'm picking 2, and that's why it's multiplication, and 10 boys, and I'm picking 2. Okay, and I get 2475. All right, 22, how many different 5-card hands exist that have 3 of a kind? Okay, we've done these card problems already, but just remember, a 3 of a kind can be 2s, 3s, 4s, 5s, and it's 2s or 3s or 4s or 5s. So it's, first of all, let's do 2s. It's 4, and I'm choosing 3 because I want 3 of a kind. And the other card, it's a 5-card hand, so I have 48 left over, and I'm picking 2 of those. That's going to be a total of 52 cards I'm choosing from, and 5 that I'm picking. But that's for the 2s, and then I have to do for 3s and 4s and 5 all the way through 10, and then Jack, Queen, King, Ace. So that's really times 13. Okay, so we get 58,656. All right, 23. Suppose there are 8 points on a plane such that no 3 points are collinear. So remember, no 3 points are collinear. So here's a point, and here's a point, and here's a point. So these are, and there are 8 points, and none of these are collinear because they can't be in a straight line, collinear, right? How many distinct triangles can be formed with three of these points as vertices? Basically what I'm doing here, math fans, it's basically a problem of saying I've got 8 points all over, and I need groups of 3 that none of them are collinear, which means it's 8, and I'm choosing 3. So 8C3, which is 56. Okay? 24. There are 20 students in a computer class, but only 16 computers in a lab. So students must take turns going into the lab. How many different groups of 16 can the teacher send to the lab? Okay, is there any order, or am I grabbing 16 kids to go in there? That's exactly what I'm doing. I'm grabbing 16 kids. So it's 20C16, which is 4845. Okay? 25. In a standard deck of cards, jacks, queens, and kings are called face cards, which you know that. How many 5-card hands containing exactly 4 face cards can be dealt? Well, it's a 5-card hand, and basically I've got 12 face cards, and I'm picking 4. Do you guys agree with that? But one of the other cards has to be out of the other 40 cards, because again, these have to be 52. I need to pick one of those. So that's exactly what this is. 12 face cards, picking 4, 40 other cards, I'm picking 1, and you multiply it and you get 19,800. And remember, card problems are always C for card, combination, right? Pete, Fred, Alice, Joan, and George are to stand in line to have their picture taken. How many different arrangements exist? Cool. You better know this one. This is definitely a permutation, and you're picking all 5. So it's 120. Okay, so B, if Fred and George must always stand next to each other, how many arrangements are there? So basically what you have is you got the Fred-George box, which they can be anywhere, so that's just, that's one of the blocks. and then we have 3 more. Okay, so do you guys agree? It's since I have 4 groups, because the Fred George group can be in the first one, second one, they can be anywhere. It's just like anybody can be anywhere. I have 4P4. And then the Fred and George are, it doesn't say that Fred has to be to the right of George or left of George, so they can be either one. So that's why it's going to be times 2P2. Okay, so you get 48 for that one. This next one, it says they must stand next to each other, but now they have to stand at the beginning of the line. So really, I have 1, 2, 3. This is not even a blank here. It's just the Fred George group. All right, so really I have 3P3, because again, this doesn't really matter as far as moving around. And then I still have Fred and George and Fred, so it's 2P2. Okay, so that one you would get 12. Good, these are really good problems. And then the last one here, how many ways can they line up if the girls and boys must alternate? Well, if you look at our what we have here, we have Pete, Fred, and George. We have 3 boys and 2 girls. So we need to start with a boy. Otherwise, you won't be able to alternate. So if I draw the slots here, we have a boy, and then a girl, and a boy, and a girl, and a boy. So this is not something we could do with just a permutation. This is actually a good slot method problem. We have 3 boys and 2 girls, but now we use one of the boys. So we have 2 boys, and we only have now 1 girl and 1 boy. Okay? So if you multiply that out, you get 12 possibilities. All right, so that's it, math fans. You know, it takes a little bit of practice to recognize that, but you guys need to be good at recognizing whether it's a permutation or a combination. All right? That's it. Adios. Goodbye.